So our goal now is to take our newly generated point cloud and then instance on the smaller cubes that are going around the main center cubes. And our very first step is to duplicate our instance setup. So I'm going to go ahead and give myself a lot of space to work, and I'm going to move my group output all the way over to the right and disconnect that. And I'm going to take everything out. So I got my point cloud over here. I'm going to take everything after, which is the instance and the scale instances, Shift E, and then move that up and go ahead and bring this in. And I'm going to work on the smaller ones first, and then we'll integrate those afterwards. So go ahead and connect my delete geometry into my new instance on points, and then scale instance out to the out geometry. Now, the first thing we'll notice that everything is just way too big, right? We need these to be smaller. So our go-to place to do that is going to be our instance on points. I'll do 0.25, so we're doing half of that value. And then the other problem that we have here is that the original fall off for our distance, it gets really big in the middle and then falls off very quickly. What we actually need this to do is extend out a little bit more. And our go-to place for that is going to be in our position and our distance. So let's break this down a little bit more. We have the position, which is the position of each one of these instances currently. And then we're calculating the distance from the vector 0, 0, 0. And then what we're doing is we're multiplying that result by this value. So the smaller this value gets, the longer this ramp is going to go, because this ramp works from a 0 to 1 value. So we're essentially taking the big world and we're scaling it down, which means that distance is actually going to go a little bit further. So it's a little bit backwards than what we're used to. So I'm going to take that math node and scale it down somewhere around 0.25. And now you can see, okay, they're getting extended. It's going further now. And these, the scale of these ones are pretty decent, but the middle of them are just too big. So how do we gain more control over this? And that brings us to step number 2, which is integrating a float curve. Well, just before our scale instances, after the color ramp, what we're going to do is throw down a float curve. I'm going to auto connect that between there. And now what I can do is just click and drag on the middle of this curve and bend that down. And then you can see that we're kind of making sure there's not very many big ones in this equation. I'm going to go ahead and take this edge over here as well and lift that up so the minimum value doesn't go all the way to 0. Great, so that is looking good. And that brings us to step number 3, which is to join the geometry. So we need to join these instances with these newly generated instances. So I'm going to move my group output over here. I'm going to search for a join geometry. Join geometry is just how we connect one tree to the other, as long as those two trees are both geometry. Connect to my bottom instances, and now we should see that we have all of them together, and we're getting closer and closer to that final result. If I hit play, we can see all of that in motion. It looks like we actually have a problem. The animation is working on the inner side, but not the outside, and it looks like I accidentally connected. Yeah, so we have the distribute points. We need to actually get this set position because that's actually what's animating this. So go to make that connection as well. So connecting that to the transform node, and now we should automatically get both of them animating. Great, and that's looking good, and I'll have the full node network in the cheat sheets below.